Hello, my dear students. Welcome to Aditya Academy. Today, we are going to see some of the previous year questions, some of the pre-final examination questions, theory questions especially. There are 2 marks, 3 marks, 4 marks, and 5 marks. Some numericals also are there. So, I am giving you this information in this video. Okay, please like and subscribe my channel and enjoy with chemistry. All right. So, let us go to the 21st question here. Explain about photoelectric effect. Right. Emission of electrons from a metal surface when a suitable frequency of light hits on it. So whenever this is called, this is a metal surface. So here incident light is falling on the metal surface. So what happens? The electrons which are there near the surface and all, these electrons will emit. These electrons will emit. These are emitting from the metal surface. That's why this whole scenario or whole experiment is called photoelectric effect. Photo means light, elect means electrons, that means electricity. This effect, in this effect, some electrons are emitting from the metal surface, okay. So next, some equation is given for this reaction, for this experiment and all. What is that equation? H mu equals to H mu naught plus and kinetic energy. Right. What is H mu? H mu is called incident light frequency. H mu naught is called threshold frequency. This is also called phi. And kinetic energy we can write with half mv square. Half mv square. That means H mu equals to H mu equals to phi. Phi is also called work function. Very important. Phi is also called work function. This is previous case set question. So next, second question. In the second question, let us see here. State first law of thermodynamics. First law of thermodynamics. Right? It's mathematical form. Okay. We have different kinds of definitions are there for this first law of thermodynamics. Look at the first one. Total energy of universe remains constant. That means the whole energy of the universe will be remains constant. This is one of the definition, and we have second definition also is there. Energy neither created nor destroyed. You might have studied in lower sections and lower classes and all. Simple definition. Energy neither created nor destroyed. Right. So now let us see here. Some mathematical equation is derived here. So what is this? Delta U. What is delta U? Change in internal energy equals to the Q. Q means heat and its work done. That means finally change in internal energy equals to the heat absorbed by the system and work done on the system. Very important, right? Go to the third question, 23rd one. Okay, right. 23rd question. What is an extensive property? What is an extensive property? The property which depends on matter. Matter means mass is called extensive property. And what are the examples for extensive property? You can see here mass, volume, H. H is what here? Enthalpy. U is internal energy. S is entropy. And G is Gibbs constant. Gibbs constant. Okay. Next, 34th question. What is common ion effect? Give an example. The degree of dissociation of weak electrolyte is further suppressed. Suppressed means decreased by the addition of a strong electrolyte, which is in common. So the degree of dissociation of a weak electrolyte, this is weak electrolyte. Acetic acid is a weak electrolyte, weak acid, and also degree of dissociation. That means it is splitting into ions. See, H3COO minus and H plus ions will be suppressed, further decreased by what? By addition of another electrolyte, a strong electrolyte like what? Sodium acetate. So what is common and which is common? Which is common? What is common in this? Acetate ion. Acetate ion is common. As per the Le Chatelier principle, as per the Le Chatelier principle, Le Chatelier principle, what happens here? What happens here? So acetic acid concentration is more here. When the concentration of acetic acids are more here, acetic acid and acetic acid concentrations are more here. So according to Le Chatelier principle, when in the equilibrium, when the concentration is increases, so it will move from higher concentration to lower concentration. That means it moves from products to reactants. That means acetate ions will combine with H plus ion and will convert to acetic acid. That means the concentration of acetate ions will decrease now. That means acetic acid concentration will be increased. This is called common ion effect. Okay, next. Consider the reaction. So look at the reaction here. PCl5 is going to splitting into PCl3 and Cl2, chlorine gas. All of them are in gaseous state. Whether the reaction is balanced or not, you check here. Yes, it is balanced. 1 mole, 1 mole, and 1 mole. P phosphorus, 1 mole of phosphorus. Cl chlorine atoms are 5. Here 3 and 2, they are 5. Right. So what happens here when the concentration of chlorine by addition of chlorine, that means concentration of chlorine increases. As the concentration of chlorine increases, the equilibrium will move according to the Le Chatelier principle. Just now we have seen Le Chatelier principle. Le Chatelier principle. According to Le Chatelier principle, the equilibrium will move from higher concentration to lower concentration. That means products to reactants. That means products to reactants, right? So backward reaction takes place. That's it. Okay. Next, decrease in the volume of container. When you decrease the volume, what is the relation between pressure and volume? So look at here. As the volume decreases, then what happens to the pressure? Pressure increases. When pressure increases, the equilibrium will shift from higher number of moles to the lower number of moles. So in which hand direction higher number of moles is there? Let us see here. In the reactant side, there is only 1 mole here. There is only 1 mole. Here, 1 and 1. Totally how many moles are there? 2 moles are there. That means it will move from products to reactants. That means backward reaction takes place like this. Okay, next. Explain the electrovalence bond. Electrovalence bond means ionic bond. What is ionic bond? Transfer of electron from metal to non-metal. Okay. So now there is a bond formation between calcium and fluorine. So what is that? CaF2. How many calcium atoms are there? 1. How many fluorine atoms are there? 2. Calcium atomic number is 20. Right. Fluorine atomic number is 9. So write the electronic configuration of calcium. You see 2882. Fluorine electronic configuration is 27. Total 9 electrons are there. In valence, how many electrons are there? 7. In valence, how many electrons are there here? 2. Okay, so from these two electrons, that means one electron will move towards to the fluorine atom, another electron will move towards to the another fluorine atom. So as a result, one electron here, another one electron here. Totally two electrons are moving here, two electrons are moving here. Totally two electrons are moving here, right? So what happens? It is losing these two electrons, and each fluorine is gaining one electron each. So as a result, what happens under here? These two electrons are gone. 288. That's why 288. Loss of electron is called what? Ion oxidation. Next, one electron is gained here. That's why 27. 7 is becoming 8. So 8 means here octet is satisfied. That's why F minus charge is becoming. F is becoming minus one more time and all. Means two fluoride ions are there. So as a crisscross method, you apply here calcium plus 2 ions are there and fluoride ions are there. Both are combining together, you will get calcium fluoride. Next, write the resonance structures of ozone molecule. What is resonance? Delocalization of pi electrons. Previous board examination question. What is delocalization? What is resonance? Sorry, what is resonance? Delocalization of pi electrons, not sigma electrons. Only pi electrons is called resonance. Okay. So now in O3, ozone structure means O3 molecule. O3 molecule. In O3, 1, 2, 3 ozone oxygen atoms are there. So now two covalent bonds are here. How many covalent bonds are here? Two covalent bonds are there. This bond is a dative bond. A dative coordinate bond is there. A dative bond is there. Now this pi electron is shifting from this point to this point. So you see as a result. So you see from here to here like this. You see here that means the pi electrons are moving here and also here. That's why these areas are called delocalization of pi electrons. Delocalization of pi electrons is also called resonance, and this is resonance hybrid. Okay, right. Explain the acidic nature of acetylene. The acetylene formula is C2H2. Next, the structure is H, C, triple bond C and H. In this, the hybridization of carbon is sp. In this carbon also sp. In sp hybridization, percentage of s character is 50. Percentage of s character is 50. As the s character increases, acidity also increases. More the s character, more will be its acidity. Okay, right. Next, explain the identification of carbon and hydrogen by Liebig's method. Right. Look, take the organic compound here. In organic compound, what is there? Carbon is there and hydrogen is there. How do you identify carbon and all? Carbon is going to convert into carbon dioxide with the help of what we are using here. Here we use CuO, copper oxide. Copper oxide, very very important. So now carbon is going to convert into carbon dioxide. How do you identify carbon dioxide? You studied in earlier classes and all. Lime carbon dioxide gas will turn lime water to milky white. Now hydrogen is there. How do you check hydrogen is converted into water? This hydrogen is going to convert into water. How do you check this water? Right, anhydrous copper sulfate, which is in white color, will be converted into blue color. Copper sulfate is in blue color. Anhydrous without water. Anhydrous without water. Then when you add water to this anhydrous copper sulfate, the copper sulfate will be converted into blue color. By this way, we can identify that is hydrogen is present. Next, write the reaction of chlorination of benzene. So this is benzene. Benzene reacts with chlorine in presence of AlCl3, that is aluminium chloride, will give you chlorobenzene. What is this one? Chlorobenzene. Chlorobenzene. This reaction is also called chlorination of benzene. Chlorination of benzene. This is called chlorobenzene. Chlorination of benzene. Okay, here AlCl3 is acting as a catalyst. What is that? It is acting as a catalyst. Catalyst.